Hello and good day. Welcome back to our class. This is Teacher Oni de Guzman, and our topic for today is Special Right Triangles Made Easy. This is Module 6 of Grade 9, Quarter 4. In this math tutorial video, we will learn the trigonometric functions of the special angles 30 degrees, 45 degrees, and 60 degrees, and how to use them to find exact values of trigonometric expressions without a calculator. So whenever we say special angle of 30 degrees, it forms a 30, 60, 90 right triangle, as well as a special angle of 60 degrees. Again, it will form a 30, 60, 90 right angle. On the other side, if we say special angle of 45 degrees, the triangle forms a 45, 45, 90 right triangle. So let's start with the special angle of 30 degrees. These two angles form a 30, 60, 90 right triangle as shown on the figure. The ratio of the size of the triangle NPG is 1 is to square root of 3 is to 2. So to help us to determine that, let's recall that the hypotenuse is equal to twice as the shortest side. Now to determine that, the angle G is 30 degrees. The opposite side NP is equal to 1. Now to get your hypotenuse NG, so that is twice the shortest side NP. So that is 1 times 2 is equal to 2. So now let's look for the side PG. Again, so NG, so hypotenuse squared is equal to the sum of the squares of the other two legs. So we have NG squared is equal to NP squared plus PG squared. However, I can derive this one as PG squared is equal to NG squared minus NP squared. Then extract the roots of both sides. So we can say that NP is equal to the square root of NG squared minus NP squared. Substitute the value of NP, which is equal to the square root of 2 squared minus 1 squared. So that is why we have NP is equal to the square root of 4 minus 1. So that is why NP is equal to square root of 3. So therefore, we can say that the ratio of the sides of the triangle NPG is equal to 1 is to PG is square root of 3 is to 2. Now that we know that the ratio of the sides of the triangle NPG is 1 is to square root of 3 is to 2. This time, again, let's recall that the hypotenuse is equal to twice times the shortest side. And the other leg is equal to shortest side times the square root of 3. So that is why PG is whatever we have length for the shortest side times the square root of 3. So since this is 1 times the square root of 3 is equal to square root of 3. Next, let's look for the sixth trigonometric function. So sine 30 degrees, recall that that is sine is equal to opposite over hypotenuse. So that is 1 why this is equal to 1 over 2. Next, cosine 30 degrees is equal to adjacent all over hypotenuse. So the adjacent is square root of 3 all over the hypotenuse of 2. So that is why we have square root of 3 all over 2. Next, the tangent 30 degrees is equal to opposite all over adjacent. So 1 over square root of 3. Now, if we will rationalize this, so we will have square root of 3. We will multiply both the numerator and denominator by the square root of 3. So that is why we come up with square root of 3 over 3. Next, cosecant 30 degrees. This is equal to hypotenuse all over opposite. So this is 2 over 1, which is equal to 2. While the secant 30 degrees is equal to hypotenuse all over adjacent. So that is 2 all over square root of 3. But if we will rationalize this, we will multiply both the numerator and denominator by the square root of 3. So that is why we come up with 2 square root of 3 over 3. And finally, cotangent 30 degrees is equal to adjacent all over opposite. So that is why square root of 3 all over 1 is equal to square root of 3. This time, let's move on to the special angle of 60 degrees. So take note that the ratio of the sides of the triangle NPG is equal to 1 is to 3 is the square root of 3 is to 2. So we will consider now the angle N, which is equal to 60 degrees. Okay, so take note that the hypotenuse is twice the shortest side, so that is the shortest side is equal to N3, while the other leg is equal to the shortest side times the square root of 3. Now, let's begin with the 6 trigonometric functions of the angle N, or that is 60 degrees. So take note that the sine 60 degrees is equal to opposite all over hypotenuse. So that is why we have square root of 3 all over 2. On the other hand, if we have cosine 60 degrees, that is adjacent all over hypotenuse. So adjacent is 1 all over 2. So we have 1 half. Next, we have tangent 60 degrees. This is equal to opposite all over adjacent. So the opposite is square root of 3 all over 1 is equal to square root of 3 as simplest form. Next, we have cosecant 60 degrees. It means this is hypotenuse all over opposite. So the hypotenuse is equal to 2 divided by the opposite is square root of 3. But we will rationalize this, so that is why we will multiply both the numerator and denominator by the square root of 3. So that is why we come up with 2 square root of 3 over 3. Next one, we have secant 60 degrees, so that is hypotenuse all over adjacent. So the hypotenuse is equal to 2 all over 1. In simplest form, this is equal to 2. And finally, we have cotangent 60 degrees. It means that is adjacent all over opposite. It means this is 1 over square root of 3. But if we will rationalize this, we will multiply both the numerator and denominator by the square root of 3. So that is why we come up with square root of 3 all over 3. Okay, let's move on to the special angle. This time that is 45 degrees. So the triangle forms a 45, 45, 90 right triangle. So the ratio of the sides of the triangle NPG is 1 is to 1 is square root of 2. Now to derive that square root of 2, we will use the Pythagorean theorem such that NG squared, so that is the square of the hypotenuse, is equal to the sum of the squares of the legs. So we have NP squared plus PG squared. Now, so if we will extract both sides of the equation, so we have the square root of NG squared is equal to the square root of NP squared plus PG squared. Then, if we will substitute the value of NP as well as PG, which is 1, 1. So, for instance, so that is why we have here square root of 1 squared plus 1 squared. So, we come up with square root of 1 plus 1, which is equal to NG is equal to square root of 2. Truly, so we can say that the triangle NPG is in the ratio of 1 is to 1 is to square root of 2. Now that we know that the hypotenuse is equal to side times the square root of 2, as well as the leg is equal to hypotenuse divided by square root of 2, or in the simplest term, we can rationalize this one by multiplying both the numerator and denominator by square root of 2. So we come up with the leg is equal to square root of 2 all over 2 times whatever the leg of hypotenuse. Now that we know the relationship between the hypotenuse and the legs of a special angle of 45, 45 degrees, let's move on to trigonometric function. So sine 45 degrees, say for instance, we consider the angle G, that is opposite divided by hypotenuse, that is equal to 1 all over square root of 2. But if we will rationalize this, multiply both the numerator and denominator by the square root of 2, so we come up with the square root of 2 all over 2. Likewise, we have cosine 45 degrees is equal to adjacent divided by hypotenuse. So this is the same as the square root of 2 all over 2. On the other hand, tangent 45 degrees, that is opposite all over the adjacent. So that is why is equal to 1. Next, We have cosecant 45 degrees. So that is, let's consider the angle G. The hypotenuse square root of 2 all over the opposite side 1 is equal to square root of 2. Also, secant 45 degrees is equal to hypotenuse square root of 2 all over the adjacent, which is equal to 1. So the simplest term is equal to square root of 2. And finally, cotangent 45 degrees is equal to adjacent all over opposite is equal to 1 over 1, which is equal to 1. So these are the 6 trigonometric functions of a special angle of 45 degrees. So to summarize our discussion on the special right angles, so we have 30 degrees, 45 degrees, and 60 degrees. And these are the 6 trigonometric functions. Observe, so we have for the sine 30 degrees, or the 6 trigonometric functions of 30 degrees, we have 1 half square root of 3 all over 2. For the tangent, we have square root of 3 all over 2. For the cotangent, we have square root of 3, and we have 2 square root of 3 all over 3 for the secant, and cosecant is equal to 2. On the other hand, if we have 45 degrees, so the sine 45 is equal to square root of 2, which is the same as the cosine 45 degrees. As well as for the tangent, 45 is equal to 1, which is the same as your cotangent 45 degrees. And this is the same as also as the secant 45 degrees and cosecant, which is equal to square root of 3. Finally, we have, okay, the trigonometric function of 60 degrees. So we have square root of 3 all over 2 as the sine. Cosine is 1 half. Tangent is square root of 3. Cotangent is equal to square root of 3 all over 3. Secant is equal to 2. And cosecant of 60 degrees is equal to 2 square root of 3 all over 3. So again, so that is actually the table for the special right triangles. Again, so this is Teacher Onen Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.